Okay, let's just dive right into one of the weirdest ideas in all of science. Imagine you have two tiny particles that are linked, like cosmic twins. You take one and you send it clear across the galaxy, billions of light years away. The very instant you measure the particle here with you, you know exactly what its twin is doing. Instantly. Sounds impossible, right? Well, nope, that's quantum entanglement.
This whole concept was so bizarre, so counterintuitive, that it seriously bothered Albert Einstein. He was so baffled by it, he gave it a nickname that stuck: spooky action at a distance. And let's be clear, he was not a fan. He felt like it had to be breaking some fundamental law of the universe.
And that's really the million-dollar question, isn't it? The one that's kept physicists up at night for a century. How in the world is this possible? Is there some kind of invisible string connecting them? Are they sending signals to each other faster than the speed of light? Well, let's break it all down.
So what is this connection? First off, it's not some secret message zipping back and forth. The truth is actually way, way stranger. It's a kind of connection that seems to completely ignore the rules of space and distance as we know them.
Basically, what entanglement means is that these two particles share one single identity. They're born as a linked pair, so their fates are intertwined. Whatever happens to one is immediately, and I mean immediately, reflected in the other. It doesn't matter if they're an inch apart or on opposite sides of the universe. Here's a way to think about it. Imagine you have a pair of magic coins. You don't know which is heads or tails. You send one to your friend on Mars. The moment you look at your coin and see its, say, spin up, you know with 100% absolute certainty that your friend's coin is spin down. Their fates are perfectly opposite, perfectly linked. And here's the part that really bends your brain. No signal travels between them. Nothing is sent. From the perspective of quantum physics, they aren't even really two separate things. They're acting like one single system that just happens to be stretched across an enormous distance. Now, this whole idea of a single system stretched across space, yeah, Einstein hated it. It just felt wrong to him. His intuition, the very same intuition that reimagined gravity, told him that reality had to be local. What happens right here shouldn't instantly affect something way over there.
So he came up with what he thought was a much more common sense explanation. Picture this. You have a pair of gloves, a left and a right. You put them in two separate boxes and mail them to two different cities. The moment you open your box and see a left glove, you instantly know the other one is a right glove. There's no spooky connection, right? The information, left or right, was there from the very beginning. Einstein figured particles must work the same way.
And this common sense idea got a formal name: hidden variables. Einstein's argument was that there must be some secret, preset information baked into the particles from the start. It was a perfectly logical attempt to explain away all the quantum weirdness and make the universe sensible again. So you had this huge showdown, Einstein's gut feeling about how the universe should work versus the absolutely bizarre predictions of this new quantum theory. For a long, long time, it was mostly just a debate. So, who won?
Well, this question didn't stay in the realm of philosophy forever. Eventually, science got clever enough to put it to the test. It was time to stop arguing and just ask the universe directly. Are there hidden instructions, or is reality really just this spooky?
And the answer, confirmed by experiment after experiment, was just stunning. Einstein was wrong. The universe doesn't have secret instructions. It really is just as spooky as quantum mechanics predicted. Now, getting to this answer was a marathon, not a sprint. After Einstein floated his idea in the 30s, the debate just simmered for decades. Then, in the 1970s, a physicist named John Bell came up with a genius mathematical test that could finally settle it. And every single experiment since then, right up to today, has shown that entanglement is very, very real.
And that proof is more powerful than ever. Just think, in 2025, scientists at the Large Hadron Collider saw entanglement between top quarks. We're talking the most massive elementary particles we even know about. This wasn't some delicate lab experiment. This was confirming the spooky connection at absolutely staggering energy levels.
So, what's the big takeaway from all of this? It's that entanglement isn't some weird little quirk of the quantum world. The LHC results help show that it's a basic, fundamental feature of our reality. It's woven into the very fabric of the universe, from the smallest things we can see to the most powerful events we can create. Okay, so it's real, it's fundamental. Cool story, but why should you care? Well, because learning to control this spooky connection is on the verge of completely revolutionizing our technology and our world. I mean, the potential applications are incredible. Take security. With entangled particles, you could create communication that is physically impossible to hack. If anyone tries to eavesdrop, the spooky connection breaks, and you know instantly. And then there's quantum computing, using these linked particles to solve problems that would take today's best supercomputers billions of years to crack.
But this goes way beyond just building faster gadgets. It's a philosophical revolution, too. When you build technology based on the idea that two separate points in space aren't really separate at all, well, it forces you to question everything you thought you knew about how the universe works. And that brings us to the deepest, most mysterious part of this whole story. We've proven entanglement is real. We're starting to build things with it, but we still don't fully understand what it all means.
So what is this connection? Is it some kind of secret communication that breaks the ultimate speed limit of the cosmos? Now, we know you can't use it to, say, send an email faster than light, but the link itself, it seems instantaneous. So what is really going on?
Or, and this is maybe the bigger idea, maybe we're just asking the wrong question. Maybe the problem isn't the weird connection, but our very human assumption that two things separated by a huge distance are truly separate. What if our whole understanding of space is just incomplete?
We don't have the final answer, not yet. But what entanglement has shown us, beyond any doubt, is that the reality we live in is more interconnected, more mysterious, and a whole lot stranger than we ever could have guessed.
So I'll leave you with this, Sichuan. What does this all point to? Is this spooky action just a weird rule of the quantum world that we have to accept? Or is it a giant clue, a breadcrumb trail pointing us toward a whole new layer of reality, a deeper physics we haven't even discovered yet? It seems the spookiness is just getting started.